really modernising how companies can work with their supply chain to drive up net zero goals, deliver social impact, and really help give that real visibility across multiple systems. I'm actually calling today from the Enterprise Hub at the Royal Academy of Engineering, where I'm a fellow, and also where I do a lot of work with startups in terms of things like chairing their Launchpad competition. And so for me, kind of working with startups, new technologies, is something I'm very passionate about, and I think is incredibly important. But here I'm really talking about the challenge projects for transforming construction. And I think for me, what's really exciting is just the incredible progress that's been made over the last 4 years since the launch of the construction sector deal. One of the real challenges that we've had in the construction sector, and I've worked in the sector for about 20 years, is that although there's been a huge desire for people to really focus on long-term value, really focus on users, one of the real challenges has been is that the short-term challenges around cost have often sort of taken precedence over that longer lifetime value. And so that the immediate cost focus has created real challenges. And I think what's really exciting is the way the system is moving towards whole life value, thinking about lifetime economic, social, and environmental value around the built assets that we create, because buildings are the lifeblood of our cities and also the infrastructure that we create. So making sure that they're built for everybody is absolutely key. And I think what's also really important is that the investment that's been made in transforming construction over this last 4 years is already delivering returns, as we'll see in a second from the following slides, and also more importantly from the people who are going to be talking today about the projects that they've been delivering, because it's actually those stories that really bring these projects to life is actually incredibly important, because it's too easy when you just look at numbers to just see it sort of really depersonalizes it, whereas the stories around the value that's been created for me is really exciting. And one of the other things which I think has been a big change, and it's taken place really over the last couple of years, is some of the changes to things like public procurement and actually the new innovation strategy that was published by the government in the summer. So over the last 12 months, I've been very lucky to be part of what was called the Innovation Expert Group at BEIS. And part of the responsibility of this group was to support the development of an innovation strategy for the whole of the UK. That was published in the summer. And one of the things which is really key in that is how procurement can be used as a lever to buy innovative products and buy from innovative companies as business as usual, to make sure that we can not only invest in new ideas through things like transforming construction, but actually now have the mechanisms for those to be leveraged and deployed on projects at scale. Because there's no point in us investing all of this money and time into products if they sit on the shelf. It's all about making sure that those can be scaled and delivered in multiple infrastructure projects, because that's where they really start delivering that innovation value. And I think for me, the other real opportunity, I'm looking forward to seeing questions that you raise, is a great opportunity for you to ask questions of and hear from real digital leaders around what challenges that they face in building their technologies, but also how their technologies can be adopted and used in different situations, so that you can really hear directly from the people who are at the heart of transforming construction. In terms of the plan for today, I'm going to be asking each panelist to speak for about 10 to 15 minutes. We'll then be moving into a Q&A session. Now, one of the mild complexities is a couple of people who are panelists have been having slight challenges in actually accessing the webinar with delays in traffic and things like that. So we're going to be playing it a little bit by ear, but thankfully our first two speakers are already here, and I'm going to provide a quick introduction to the first two speakers to make sure that you know who they are. So first of all, you're going to be hearing from Rob Stiles. Now, Rob is the founder and director at Future Joinery Systems. He's an architect by background and leads a configurable BIM tools project, which is about delivering efficient fabrication, combining push-button manufacturing and BIM software to create bespoke joinery. We'll then be hearing from the duo of John Bedford and Franco Chung. So John is technical director at Walsall Housing Group. He formerly worked for Accord Housing Association. And Franco is the research group lead at Birmingham City University and previously a quantity surveyor in Hong Kong. And together they've been working on West Midlands DFMA, which is about cost efficient and low impact and high performing houses at scale using automated manufacturing assembly processes. So for me, what I'm really excited about is to hear from the people who are really at the heart of innovation in our sector and to hear what advice they have for the rest of us too. So with no further ado, I'm now going to hand over to Rob to do a short introduction.
Hi there, I'm just going to share my screen then. Right, can you all see my screen now? Is that looking good? Right, because I'm blind now. So, okay, yeah, my name is Rob Stiles. I'm an architect. I've got about 15 years worth of practice experience. And about 4 years ago, had a slight change of direction towards tech, software, digital fabrication, and we started a company called Future Joinery System. We're probably one of the smaller companies in this grant allocation. We've been successful in 2 Innovate grant applications actually, and I think it's worth stressing that these grant competitions aren't just for the larger companies. I think the smaller companies have got a lot to bring to the table. So what I'm going to do today is talk about a few recognised problems in the industries. I'm going to talk about a couple of kind of concepts, and then hopefully you'll start to see how our grant proposal starts to solve some of those problems with the concepts that I've been kind of going through. So first of all, it doesn't really need much explanation. You already know there's lots of push for better efficiency, expediency, quality and assurance. There's a massive amount of wastage, reducing carbon, also combining kind of quality risk and procurement. And then there's a growing skill shortage and labour pool problems that are coming up. There's also a recognised kind of lack of digital literacy and tech readiness in the industry. But at the same time, with those problems, there's actually been some significant advancements, primarily from a tech and software side. So part of that is BIM, which some people love and others kind of resist against. There's also a massive move to cloud storage and a much greater potential of integration between collaborating partners. And then there's digital fabrication, which is growing in its kind of saturation in the industry. So, okay, first of all, again, we're a small company. We work on small projects with small contractors, and at that level, BIM isn't really working in the way it should do. It doesn't have the saturation that it does in the much larger government projects. And kind of one of the questions is why is this? And for us, it's because that software doesn't have direct cost and time feedbacks for the designers. And how do you build those feedback systems when you're designing bespoke, design-focused elements? What does bespoke even mean in the world of digital fabrication? And if you have lots of options and lots of design configurations, how do you manage a library of billions of configurations? Also, that's problematic is a link to the digital fabrication processes that are out there. Why are we having to do the work twice? And how can you get the digital twin to drive its physical kind of counterpart? So one of the things that's discussed a lot, that might be familiar to a lot of you, might not, is parametrics and what that actually means. So parametrics is just really a way of designing without a metric reference. So it allows one definition of a design to exist in millions of different combinations, and you don't need many configurations, many materials, many options and many features before this balloons into literally millions of different configurations for even quite simple objects. The objects can look very different, but what's important is they all come from the same parametric based model, and what that means is that bespoke isn't really unique. Bespoke is made to fit, it's made for a particular customer, and it's got particular features, but effectively one design can effectively be the same design if it's defined in the right way. Then we've got digital fabrication. So we concentrate on CNC, that's 2.5 axis CNC, and that's primarily because it's relatively well established, if not utilized in the way it could be, rather than your plastic printing or any of the other kind of options that are still growing. The major problem with CNC is there still lies at a big gulf between the architect's design intent and how that data carries it through to manufacturable data sets. And then another concept that I want to put forward here is what's called push button manufacturing, which is simply pressing kind of make rather than press and print. Now that exists in a lot of product design world. So you were prototyping a mobile phone, you can press make, and you don't even have to own that fabrication kit in your lab. In the States, you can send it off. Somebody somewhere makes different components, comes together, and arrives FedEx on your door in a couple of days, and that's the prototype there. So that's push button manufacturing. So how do you build push button manufacturing for the construction industry, where you've got loads of different bespoke items? And the trick here is that we believe is in the configurators. So our kind of grant competition proposal was about providing a link between parametric software, which stores the design definition, through configurators that push directly into the BIM software. So the digital twin acts like the kind of the shopping basket in an e-commerce site, with a kind of proceed to checkout kind of function, giving you, as you configure, you get direct cost feedback, which then once you place that order, takes the same data set and pushes it all the way through to machinable parts, which then get delivered to kit like a big Airfix model, for simple site assembly, because all those coordination and configuration problems have been considered. So what we've got here is some of the progress we've made so far. This is running in SketchUp, where effectively we're bringing in a series of models and configuring them to the designer's needs. Now, what's important to stress here that this isn't being generated within SketchUp. It's being bridged directly from our parametric software, which contains a much higher level of detail than is needed for these BIM models. So the user is able to configure and pull through that information, and then configure it as they need to, and then effectively they're getting cost and time feedback, because the parametric software knows exactly how much material is being used, and then you're able to effectively press make, and it can get delivered to site very quickly for site assembly. So if we move this through a bit, which we're running out of time already, there you can see there's one of the room dividers that's coming in. It's not just about cabinets. We do really quite complex geometry, and it's being pulled in and it's being positioned here. So let's move on to the next. The software also produces full, DFMA design assembly instructions for simple site assembly. We've got here a staircase. This is a photo of a staircase that we installed in Oxford. Here we've got the assembly animations that again come from the same software that allows the joiners to take the complex software, the complex geometry, and assemble it just using simple site tools, maybe biscuit joiner, but mostly just a drill driver and screws. And then just let me. Okay, and here's another staircase that I'm just going to go through some of the projects that come out in the last 3 years. Some of these started right at the very beginning of this grant project, but most of them have been delivered using the technology that we are slowly beginning to build through this grant project. This is Staircase in Bristol, which we won the Wood Awards for in 2020. Again, it lends itself to cabinetry. The kitchen market's quite well established and has been a good one for us to target, but we can completely bespoke every cabinet. There's no set sizes. There's no set internals. We can configure quite a lot of stuff there. This is a commercial project where we're working quite tight budgets for a developer. Kitchens, bedrooms, and bathrooms. Here's that room divider that you saw being pulled into that animation there. I mean, here that can be configured in loads of different ways, loads of different sizes. It gets delivered to site for really, really simple install. We've got more residential fit out. I mean, one of the major advantages here are massive cost reductions, but also huge lead time and lead-in advantages. So here we've got some quite complex geometry that's being delivered to site as this Airfix kit, but really simple assembly. We've also been working on a few larger commercial projects. This office fit out in Bristol. Bookshops. There's a lot of shelves in the bookshop. We fitted out a full bookshop in Cardiff, independent bookshop. But also, it doesn't have to be fitted furniture. This is a corbel that we worked with on an ICF project. It's picking up the external skin of the stone where that structure doesn't need to go any further down. And this is a retaining wall that then gets buried against that. So it's basically any places where we need complex geometry and a high degree of accuracy, then the system's entirely relevant. Allows us to bring designs quickly to market. So what we've got here are some COVID screens that we knocked up very quickly because there was a big demand for that a year or so ago, or a bit more than that now. So that's one of the first things we did because we can move very quickly. And again, because we don't have to program all this stuff, we just build the parametric models. We can pull those through to the user's CAD software. It doesn't have to be SketchUp. The same principle works in Vectorworks and in Revit because they can support a browser, and our stuff's held in the cloud, so it's being pulled through all the time. And then this is a nice example of how you get collateral impact of these innovation grants across the industry. So this is a text that we didn't really know existed. We were contacted by an upholsterer who had a problem because they couldn't find enough joiners. They didn't have joiners in their workshop. We previously outsourcing them, and there was no resource out there for them to use. So we built them a configurable set of their banquet seating. Later on, this can be hosted on their website for their clients to configure. It allows them to configure multiple configurations of different pleats and head rolls, etc. at the back, and then gets delivered to their site, to their workshop as a kit of parts. And because they've got some skilled guys there, with lots of staple guns and nail guns on their pneumatic systems, they're able to just assemble these like a big Airfix kit, nail them together, and then upholster them. And it's increased their capacity to deliver, as well as kind of opened up a lot more options in terms of configurations, produced drawings for them to give to their clients for real-time feedback, and avoided errors. So we already had one job where, when the client looked at the pictures, they decided to increase the height a lot more, and that wouldn't have happened before. It would have turned up, and then they would have had those problems. So just
I'm just going to do a quick time check.
Yeah, this is the summary page. Thank you. So really, that's what our project's been about, is configurable tools from which link together the parametric software through pushing it into BIM and using the BIM model like an e-commerce shopping basket. Yeah, and we're just getting to the end now of our grant period, and looking to kind of scale up and take it to the next step. Okay, thanks very much. Elizabeth, are you going to hand over to John, or?
Yeah, so thanks, Rob. So yes, John and Franco, it'd be lovely to hear from you on your project.
Thanks, Elspeth. I'll leave the technicalities to Franco. If you can stop sharing, Rob, we can try and pull up our presentation, if that'll work. And love your stuff.
I think it seems that Rob needs to, okay, probably I can do it now. Okay.
Thanks, Franco. So you got a bit of a double act from Franco, my colleague, and I. Franco will introduce himself in just a moment. But my name's John Bedford, and I'm Technical Director at WHG, Walsall Housing Group. My journey through life has seen me in private architectural practice for the first 24 years. And then for the last 15 years or so, I've worked in the public sector in 2 housing associations, having designed and managed an off-site manufacturing facility, an architect's practice, and indeed the construction delivery team. So I have a little bit of experience in house building. But the presentation that I'm going to take you through, if Franco can share it, has quite a longer title actually than the one that you've seen on the agenda. It's actually a collaborative, knowledge-based DFMA approach to building cost-efficient, low-impact and high-performance homes. And the reason I started with that is because the first slide, when Franco, no pressure, Franco, when Franco can find
I'm
it.
still working on the to make sure that it is possible. I'm really sorry. It seems that there's some.
To share my
Maybe
screen
okay
already.
now.
You ready?
Yes, yes. If you give me like 1 second, then it should be okay. Share.
Thanks, Franco.
Okay, and here we go.
Super duper. You're a star. So if we can go to the next slide, as the intro's done. So the reason I started with a collaborative approach is because there was a consortium of 6 of us that worked very closely, and we couldn't have done it without an equal amount of effort into what we were trying to do. WHG, who I work for, we're an RP with 22,000 homes across the Midlands, and as an informed client, it was very important to us that we understood completely what was available through the DFMA platform for house design. And in order to do that, we approached 5 other consortium members, and you'll see who they are on this particular slide. And there's 2 of us today to present our findings. Next slide, please, Franco. Thank you. So we had 5 key objectives with our particular project, and that was to design collaboratively lightweight steel framed, designed for manufacture and assembly houses so that they're scalable, but key to that, they're cost efficient and environmentally friendly. We looked at the embedded energy efficiency, which is very important, and Franco will elaborate on that in a few moments. Evaluate as well the house DFMA envelope, and that's, I'll come on to optimizing the automation capacity, but that was also about capturing every component and standardization of the design that we've come up with. Look at various assembly options, because it's quite easy to run to the bottom line and say, okay, we're going to go modular, or we're going to go panelized. But for me, it was more about being really flexible and looking at a design that could do all of those things as and when the site or the project dictated. And the key to this, the uniqueness to this, which is Franco's baby, and I'll let him explain that, is the KBE tool, the knowledge-based engineering tool, which is a platform that allows you to pull out information around predictability of time, cost, not only quality, but deliverables, and also all of the embedded energy efficiency in the design. Thanks, Franco. So the DFMA house design, which was obviously the core to this, because that's what we were trying to create, used a panelized system. So it's a predetermined size of panel that could then provide a volumetric system. And just at the bottom of this slide, you'll see some CGI configurations, some 3D configurations of how a house comes together. So you've got 6 modules basically that are predetermined size, predetermined replication that can be easily manufactured, and they can move and swap around within the configuration of the home itself. So you could have a kitchen in the middle, you could have it on the front, on the back, lounge on the front or the back. But really what's quite interesting is that you could take all 6 modules to site as they were, assemble it if you had a really tight site, or you could pre-assemble them and deliver it to site as a whole, depending on the ability that one had for the site. So we looked at standardizations of windows, doors, facade systems. You can see that on the slide. I won't read everything, but obviously the interfaces and sub-assemblies were thought of in a great deal of detail before we actually did a prototype, really. So next slide, please, Franco. One key thing to this, though, was looking at the energy efficiency, and it wouldn't surprise you to know that obviously we looked at a really highly efficient envelope. But what we also wanted to look at was 3 different scales of energy efficiency within the home: heating, hot water, lighting supply. And we came up, it took us ages to think about it, didn't it, Franco? But we thought bronze, silver and gold might be the best way to describe the 3 different standards. And you'll see from that, I'm going to take you through it all because of time, that you'll see the different standards of energy efficiency that were applied into the house concepts. Gave you anything from electric panels and a mixed-G hot water cylinder all the way up to air source heat pump technology, PV, battery capacity, and the like. So that took us a great deal down the journey. Next one, please. Okay. So to summarise my few slides before I let Franco loose on the KBE stuff. We've got a DFMA house platform that was modularised, if you like, so that it could be a hybrid, a volumetric and panelised delivery approach. We had 3 different energy standards depending on the affordability of the home in its first instance and the aspirations to get to zero carbon, certainly at least the Future Homes 2025 standard, which in fact wasn't even a thing when we started on this journey in 2018. And really importantly, the knowledge-based energy tool, which Franco will take you through, which is, we think, a very unique and superb output from this project that we are developing and taking much further. So hand over to you, Franco.
Thank you. Okay, so let me just try to recap just a little bit about the project. So we're talking about within the project, we have a platform that actually allow people to allow particularly user to consider the use of DFMA house. And so the platform itself offer the user the choice of different type of manufacturing options. So we're talking about if somebody wants to build their house using a panelized method, and within our DFMA house, they can make use of a choice. And then if they want to evaluate the cost, if they want to evaluate the time as well as the CO2, they could make use of a knowledge-based engineering tool to carry out that assessment. So that is the ultimate goal, if you like. And as we all know, these days we make use of BIM to develop the building model. The benefit of having a platform idea is that we will have the design produced in advance, and then people can assess the choice using the KBE tool. So that's the concept in behind. And within the project, we develop a proof of concept tool, which we integrate information from BIM model, we integrate information from cost database, we integrate information from CO2 database, and we also develop an interface for user to input information to evaluate the various options. So what we have developed is actually a tool that contains 3 different functions. The first function is for any user that they just want to have a high-level comparison of maybe alternative system. And then we're talking about within our platform, we have 4 options for people to choose, and they are typically like an on-site system, a steel frame on-site system, a steel frame panelized system, a steel frame hybrid system, as well as a volumetric system, which is a pod or modular design that John refers. So somebody who has a site who wants to evaluate the implication, they can make use of the interface, and then the interface will capture information from the BIM model and other like databases to generate a very detailed estimates, which the system is shown using table as well as dials, in which people can make use of it to compare and evaluate. And here, like as shown on the top part of the screen, you can see the dials, you can see the tables. Basically, it enable a user to dig deep into the different level of information to evaluate the cost and evaluate the CO2. And the way that we design this is we make use of a costing system for the cost part is called activity-based costing. So basically the operation is broken down into the activities and then we cost it. And because it is manufacturing in which we can, we have already developed the production process. So we basically cost it according to the production. That's why it allows people to dig deep into the different parts and evaluate the production. So that's one part. And then the other two parts, really, it allows people to make use of semantic search to know how actually the data is constructed and to extract parts that they want to find out, as well as to if somebody who has some kind of like a computer knowledge, they can then dig deep to evaluate. For example, one queries raised in the last part is actually the production time for a panel. So you can actually dig deep if you don't want to make use of the already structured information in the interface. And if you know the computer language, you can then set the queries and the system will then respond to you. So it allows user, if in the future somebody wants to evaluate instead of like, let's say cost and time, they can actually build an interface to actually like take information within the system. So in addition to that, the project also produced a prototype building. So we actually have a prototype of a DFMA house, and it's situated in Hadley's factory, one of the partners within the project. And this is, as you can see, the final product. It pretty much looked like any on-site traditional method construction. So the great thing about this is that it tries to at least break the hurdle of, in the past, a lot of people have this idea that if it's modular construction, they probably doesn't look like a typical house. So the benefit of the system is that we create quite an adaptable, scalable solution, yet the outcome is something that the market is quite close to what the market really needs. And I think one thing that we want to, perhaps I want to explain a little bit, I guess, in the end is we got funding from the core, and then we actually tried to see how the development could potentially generate some benefit. And then here are some of the indicators, if you like, that we evaluated. And some of it has been actually like reported, if you like, in this new book that has been published called Exploring the Green Economy. And there's a chapter, actually, we try to summarize the result. And we also report this to Innovate UK. That is a few things. For example, if in the future, the building is going to make use of the highest energy standard that John mentioned earlier, we actually make use of energy system catapults, high fidelity model to evaluate it, and then they carry out a simulation based on a 5 persons family, as well as some other scenario. For 5 persons family, we're talking about the use of energy in a year. The bill is less than £200. So it's really, really energy efficient. If that sort of system can be used and applied in other buildings in the future, in other houses in the future, then there is a high chance that there would be significant saving. That's one aspect. Another aspect is the way that we anticipate the use of modular construction using the DFMA house. The P manufactured value, just the part that is done within the factory for the production, is close to 45 to 50%. So if you add other modules, for example, window itself, definitely that would be like higher than 50% of the value. So again, that's something that line up with what the transforming construction challenge would want to see. And obviously, there's also benefit of the use of volumetric construction if in the future the DFMA house is going to be built. We're talking about an individual house just the structure alone to be built on site, it will be taken for 2 or 3 weeks, and then it saved the construction period significantly. So again,
so Franco, can I just do? I'm just going to do a quick time check.
Yes.
So thank you.
Yeah. So the exploitation is basically the last part that I'm going to explain. Is exploitation part that Hadley has already invested 3.5 million to the project, in which they have acquired a factory as well as building up a production line. And then Hadley, together with BCU, has just won at KTP to develop that KBE tool further, for a tool that enable them to make use of it to engage customer as well as develop their product. And WHG and us, we are again try to carry out a study to evaluate steel as against timber product to see the implication in terms of carbon emissions. For North Mill, we understand that they are trying to learn from this DFMA experience and apply that modular design to other products that they are trying to work together with other clients. And then this project itself is a demonstration of energy system catapults, a high fidelity modeling tool. And again, QM Systems, they are production engineer. This experience allowed them to approach other suppliers and help them to develop the production line. I think that's pretty much a summary of the exploitation. And these are the some of the publications that we have done. And I'm sure probably most of the audience in here is not a subject that they're interested. But hopefully, if you are interested, you can take out the PowerPoint to find out the references. And that's the end of the presentation. Thanks.
Thank you, Franco.
Yeah.
Thank you very much, John and Franco. That was fantastic, actually. I've got lots of questions now, but before we do, I'm delighted to say that Dan has made it. You've made it back from London. And as somebody who is the CTO of my global home, who's creating smart mass market homes that adapt to changing lifestyles, I think this sounds like a perfect segue from what both of you have been talking about. So I'll hand over to you now, Dan. You're on mute, sorry.
Can you hear me okay?
Yes, we can, thank you.
Okay, can you see my screen?
No, you'll need to share a screen.
Okay.
I love the fact that it's still in 20, and after 12 months of working from home, we're still all in the position where we're still dealing with mute and sharing screens.
Especially, it's a good look for a CTO.
Absolutely. Don't worry, you're in good company. We've all had the same challenges today.
Okay. Brilliant. Okay. Well, so hi. Thanks for having me. I'm Dan Eads. I'm CTO of my global home. We started life as in California as a modular home manufacturer, and we still have a long research and development program running to actually build our own modular home systems. But we have taken a strategy to commercialize our digital offering first and establish a new smart home standard as our first entry into the marketplace. So just wanted to talk first, obviously I know lots of these people on this call from the Innovate UK funded projects. Just wanted to kind of extol the virtues of the Innovate UK funding program. We're very pleased to win our first grant award in 2019, which allowed us to establish the Innovation Centre in Guildford that you can see in front of you. We found it a great introduction to working with the university. This is actually built on the University of Surrey grounds, out just in the shadow of the cathedral. It's an amazing facility where we get to showcase our technology, but also get to collaborate with the university researchers and also in the wider construction innovators as a whole. And it wouldn't have been possible without the support of Innovate UK through the Transforming Construction Challenge as part of the Industrial Strategy Challenge Fund. Following on from that, and as a successful result from that, we actually applied for another project, which we're very glad to be awarded. And this was a £9 million project to build a 25 home or 25 bedroom development on the grounds of the University of Surrey again, in conjunction with some industry leading companies, and this will serve as an inhabited demonstrator of our technology and our approach to modular manufacturing and adaptable living spaces. So again, very grateful to being able to work with the University of Surrey and Innovate UK to deliver such an exciting project. We've obviously had a few challenges along the way with COVID, delaying planning permission and delaying relatively most of the activities on university campuses, but with the support of Innovate UK, they've been very flexible. Get ahead behind the scenes to hit the ground running when planning permission is granted this week. So that's a summary of our activities with the UK government. So our first, we decided as a business to actually commercialise our smart home offering ahead of our modular manufacturing offering. So as part of the modular manufacturing approach that we were taking, we had a very strong focus on home controls and smart home automation. We researched the market. My background is actually in smart home automation for very rich and famous people's houses. Traditional smart homes are based on big racks of equipment in people's basements. It's very expensive. It's very closed protocol. They are very focused on hardware-driven solutions. They don't really go very much further than pressing a button in a home and something happening. And the UI is often very outdated in most instances. It's very clunky, out-of-date UI design tools to deliver the actual user interfaces. Obviously, the market has been somewhat democratized over the last few years within the kind of the emergence of the IoT market, and very much IoT devices are fueling the interest in smart home technology in terms of the wider audience. But at the moment, it's still a very fragmented marketplace with many kind of individual applications and individual technologies kind of fighting for market dominance and relying very heavily on cloud-to-cloud integration, which is obviously very risky from a cybersecurity perspective. But also those interoperabilities can actually be shut down overnight as one company discovers a weakness in their cybersecurity credentials or decides as a business decision to actually close down their APIs from one company to another. Property developers really struggle with this approach because they have to create multiple accounts, buy products from multiple different vendors, and the handover process for actually homes at the end of the process of building smart technologies into their homes is very challenging as you have to hand over multiple different systems. So we've taken a very different approach to the smart home marketplace. We've looked at it from a very software first approach. We believe that the future of smart homes is through embedding software deep within the home at the point of it being constructed, and eventually being able to retrofit a smart piece of software in the middle of everyone's house eventually. But we focus very much on the new build home market to start with, and embedding that software right at the heart of the home at the point of construction is a great challenge for developers. So our business model actually allows them to do that at scale. And our approach is a very holistic approach to smart home control. We focus on deploying a very powerful computer within our hardware at the center of a new build home that allows us to have edge integration rather than cloud. So our cybersecurity credentials are much stronger than IoT-based cloud-to-cloud integrations, and importantly, the cost of our hardware is very low. So we're actually sitting in between the best of the two worlds I described earlier. We obviously have cloud extraction of key data. If users of our smart home systems want to gain better insights into their homes and allow them to be more energy efficient or interact with more complicated features on our interface. But effectively, if they want to just use their home in a standard way, there's no risk because there's no internet required. And what this allows is for us to deliver a very holistic smart home experience to people when they move into their new home, and build very powerful applications to be built on top of that, the top of that core functionality over time. So in order to deliver this software, we need a very robust hardware underpinning. We're very pleased to be in partnership with a leading electronics manufacturer, Beckhoff, whose hardware powers the BMW supply chain for every BMW that's manufactured globally. So some very mission critical applications. That gives us a very robust underpinning and allows us to sell our product into the marketplace with complete assurance that that is going to be incredibly reliable. So we've built our own hardware solution, which is based around a domestic fuse board. The domestic fuse board is installed at the center of the home and is where all electrical appliances and future electric vehicle charging points and connectivity to solar panels and other energy storage and energy generation devices. So all the cables run back to our smart fuse board. It's exactly the same electrical infrastructure as it would be with a normal fuse board. There's no learning curve for incumbent electrical contractors to install it, so it's very easy for developers to have built into their properties. And the light switches and thermostats we've developed to use a standard cabling infrastructure and also have standard terminations at the back. So there's no need for specialist companies to come in and be just another trade on a building site. So we can supply that to new build homes that are built in traditional construction methodologies, or we can provide that hardware to modular manufacturers to be built into their homes as part of their modular manufacturing process. Everything is completely regulated and completely certified under all of the British standard requirements for electrical infrastructure within the home. So really what we're doing through this approach is appealing to developers' needs to who want to build smart homes, simplifying the design and installation process. We're kind of disrupting the marketplace, but not disrespecting it. We're working alongside existing traditional construction methods as well as new modular modern methods of construction. And we're simplifying on-site implementation through our hardware and importantly simplifying the handover and adding great value to property developers. We see a great level of interaction and a great deal of uptake in the marketplace with developers, which will then assist us in being able to build on offering to those developers over time as we develop more of our modular methods of construction in line with the rest of our business plan. And by having software at the heart of the home, that allows us to then develop our business model into a holistic platform-based approach. So we are in the process of automating and streamlining the smart home design configurator, which allows developers to actually engage with us, upload their BIM model or upload their 2D plans and get an automated cost and benefits analysis appraisal back of using our technology. Importantly, that also allows us to act as a gateway and a route to market for other third-party companies that we can integrate with. And the developer gets an analysis of how much this is going to cost. And our aim is at every single point to be cost neutral to the developer through our business model, to present a carbon offset saving through using technologies that save carbon at the point of deployment, and a future embodied carbon analysis of how that home is going to perform over time. That allows developers to gain access to future green finance initiatives. It allows for sustainability criteria to be presented as part of the planning application, and importantly, it gives a practical tool for the developers to engage with us at the point of building those homes to actually build sustainable innovation into their developments at the point of deployment. We have a data repository which sits underneath our platform called a logbook. Each home has a data repository which essentially contains all of the specification information at the point of deployment, but is also updated over the lifetime of that property to be continuously updated with energy usage, activity, transactions, updates and upgrades, and continuously serves as a source of information for whoever owns or lives in the home at that time. It's a bit of a complicated diagram, but effectively.
So Dan,
yeah.
It's Elspeth here. Sorry, I'm just going to do a bit of a time check because we've also
sure.
got Raphael here. So if we can just wrap up, that'd be great. Thank you.
Perfect timing. I'm on my last slide, so that's perfect. So we have our platform. We are developing in 3 stages. We're currently building out the develop platform, which allows developers to have the technology built in at the point of deployment of homes. We're then moving on to the sell platform, which allows homeowners to buy these smart homes and actually specify upgrades and understand how the home is going to perform over time. And then building out eventually the occupy platform, which allows home owners and home occupants to interact with an ever-growing ecosystem of different goods and services. And they will include digital healthcare, smart maintenance and facilities management, fitness and well-being, a large focus on energy optimization, and concierge and marketplace activities to allow people to engage with their local communities. And that's it. So it was a good time check, Elspeth. Thanks for that. I noticed a lot of synergy between what we're doing and what other people have been talking about today. So I'd be really keen on being in contact. Specifically, I can see John nodding. I was very interested to hear what you said. So I'd be very, very keen to take any questions or maybe form some new relationships off the back of this.
Thank you very much, Dan. And finally, I want to hear from Raphael. So I'm glad that you've been able to make it as well. It's been, everybody's been arriving as we're presenting, but I'm going to ask if you can keep this quite short. Is that possible? So Raphael is the co-founder and CEO of Converge, and they've got 3 transforming construction projects, which is exceedingly exciting. So Dan, if I can ask you to stop sharing so that Raphael can share. And then Raphael, if I can ask if you can keep it quite short so that we've got enough time for a Q&A. Thank you.
Of course. No, hi, everybody. I'm Raphael Scheps, co-founder and CEO at Converge. And then Elspeth, how long have I got? Just to get a sense of how quickly I should go.
If you can go 10 minutes, that would be absolutely amazing. Thank you.
Perfect. So give me 2 seconds to share my screen. Cool. So can everybody see this? Yes, awesome.
Yeah, perfect.
Cool. So I'm the co-founder and CEO at Converge. And so my background actually isn't construction. I'm a physicist originally, but have been building Converge for 6 years now. And our mission at Converge is to build the future more efficiently, safely, and sustainably by digitizing physical reality of construction. So we actually deploy sensors that look at anything from materials such as concrete and its performance to the location of assets, and utilization of those assets, as well as the environmental conditions on the site. And we integrate all that data into what we call construction DNA. So construction DNA really is a platform that is able to fuse physical data, this data from sensors with construction data. So with BIM models, with schedules, with cost and sustainability data. And we think of it as more than a digital twin. We think of it as an AI system that's actually able to reason about causal links in construction using data derived from physical processes. Underpinning or built on top of rather construction DNA, we have 3 key pillar products: concrete DNA, structured DNA, and logistics DNA. And I'll talk about how a number of these were actually used in the context of a number of transforming construction challenge grants across actually 3 different consortiums, so 3 distinct projects that we delivered over the last, I guess, 2 to 3 years, really. Maybe just as a brief touch point, concrete DNA is all about optimizing the concreting process. So it's made up of a sensor that you embed in concrete and a data platform to manage the concreting process itself, provide kind of AI strength predictions on the behavior of that concrete, and help improve the quality and the speed of concreting, as well as the sustainability of the overall process. Structured DNA is a set of structural sensors that look at anything from movement, so tilt, strain, loads, during construction. So quite often when people think structural health, they think of post-construction monitoring, but we actually look at structural health during construction to help reduce rework and increase QA. And then through logistics DNA, we're really optimizing the logistics flow of offsite construction and the assembly of various kits of parts. All of that is powered by the signal sensor, which is at the core of our technology. It's a reality capture platform that helps us capture the physical world on the job sites and ultimately make construction more cost-effective, faster, safer, and greener. So there's 3 key grant projects that we were involved in, one of which we led, and that was the core grants in consortium with the Royal BAM Group and BAM Nuttall. So I'll touch on that one first. We also have been participants in the PBBS grant and the Hyperpile grant. So what I'll be doing is kind of providing a bit of an overview of what we actually delivered, the challenges we faced, and the results out of each one. So core was all about designing and building an AI-based system that could actually predict the behavior of concrete. So Converge had already built a solution that could monitor concrete and that could provide real-time performance data on how concrete was curing. But the next step was really to actually start integrating that data with the weather forecasts and all sorts of other data sources, including scheduling data and BIM models, to actually be able to provide a forward-looking view on the behavior of concrete. And so actually the goal was to deliver that engine that was able to do this with an accuracy of above 95%. That prediction ultimately allows projects to take a much more data-driven approach to decision-making on the site. So we worked very closely with BAM Nuttall, who at the time were contracted to construct the new taxiway at London City Airport. And you can see a photo there on the right of one of the Converge repeaters actually on the site, just as I think a plane was arriving on the runway next door. I mean, it was a pretty challenging environment because you had to be operating airside for the duration of the pilot. But essentially what BAM was doing was building a number of kind of decks on this taxiway and then kind of topping that up with some in situ concrete. So you had a number of precast concrete decks and an in situ topping that brought it all together. And concrete strength development was key because you needed to traffic each one of the individual elements with a crawler crane to actually be able to move on to the next part of the job. And clearly, from a safety perspective, it was also really important that you do that at the right time because this was being built on top of the canal. And so we worked very closely with the BAM group more broadly to actually train essentially an AI engine to be able to predict the behavior of concrete and also link that up into the BIM model at London City Airport, which actually allowed us to get to the point where we were making predictions down to the hour actually on when a particular component was going to reach strength, which allowed the crawler crane to actually move on to that particular element and then construct the next element in that sequence. So that was kind of a huge result, which actually on the overall program meant that across a stretch of about 4 months of concreting, we were able to reduce a program time by somewhere between 2 to 3 weeks. So a large chunk of the program. The seasonal variation have quite a big impact on concrete performance, and they can kind of typically slow down construction activity. What was quite interesting as well was to be able to actually start seeing the impact of seasonality on BAM's ability to optimize their schedule. And we were able to enable them to do that on a dynamic basis in real time, ensuring that actually in the depths of winter, they were taking a safe approach to delivery, whereas actually when it was warmer, they were able to take a more efficient approach. So, you know, we increased the productivity of that particular job site, but then beyond that, I think the impact has been that we've ended up rolling the feature out to our wider construction DNA and concrete DNA suite of products. And so this was really pretty seminal for Converge in the, I think, 100% of our sites are now being able to benefit from that particular feature, which creates a systemic industry-wide impact for the industry, helping reduce construction costs, increasing productivity. And I think the interesting development that comes after that becomes you can start to refine the algorithm to provide other outputs. So not only advise on when concrete will hit strength, but what concrete you should be using in different environments. And that has the potential of having huge impacts on sustainability and carbon content of job sites. So we're in the process of rolling that out across a large body of sites. The feature is active in the UK, Hong Kong, Singapore, Australia, I think over 10 countries now, which has been really exciting and a really great kind of story of how we've been able to put that kind of funding to good use in terms of driving that change that we're all looking for in the industry. On the Hyperpile end, we were actually working with Kelpray, who were the lead partner, and a number of other consortium partners, including SEM3, so the David Ball Group, and looking at foundations. So really in this context, we were actually looking at the use of sensors in foundations and piles. Kelpray was building a hollow pile with a view of actually reducing the carbon impact of their piles. So they've named this the Hyperpile. It's hollow, impression-based, precast, energy generating and reusable, and it's smart. So what Converge brought to the table was the ability of making that pile smart, monitoring the behavior of that concrete in a piling environment, and then ultimately the structural behavior of that pile in the longer term. And so we had to kind of redesign the sensor device to actually operate in piling conditions. That led to significant challenges, actually. When you're in the ground, it's a lot more challenging to get wireless signal out. It's also a lot more challenging to position your sensor because a cage actually moves about quite a bit, and you could end up sinking a bit too far. And so by collaborating across the consortium over a period of 18 to 24 months, we were able to run several field trials and refine the technology to monitor the ultra low carbon that was being used in that hollow pile, and ultimately overcome a number of these challenges. I mean, I think we're still working through wider commercialization, but what's quite exciting is that we're now in the process of demonstrating that these piles do behave the way you'd expect them to behave, that you can scale them to traditional piling applications, and that they have a tremendous impact on total embodied carbon and can be reused in the longer term. So we're working very closely with Kelpray and our wider industry partners to commercialize the Hyperpile. So that's project number 2. And maybe just to touch on PBBS, which is the third TCC grant that Converge has been involved in. This one is still an active project. And actually probably the largest consortium we've been a part of. I think there's 8 or 9 consortium members. It's led by Langer Rook, and this is really all about building out a kit of parts to streamline the end-to-end project delivery process for kind of off-site construction. So a combination of a physically and digitally configurable kit of part that again, by design here is smart. In this context, Converge was actually piloting Logistics DNA. So Logistics DNA is our logistics optimization product and Structure DNA. So we were actually able to start characterizing the structural behavior of that project, but also look at the productivity rates and installation rates for that kit of parts. So what you're seeing here is actually a signal sensor being installed on the bottom right to a strain gauge within one of the prefab components. And the monitoring spans the whole life cycle of that element, from the point at which it gets prefabricated in the factory to the installation of the assets, at which point we're tracking its location to its life cycle so that we can actually start validating its design. And so we were able to get both that structural data and that logistics data to really provide an integrated view of the delivery and installation of that kit of parts. I mean, several challenges that were faced on that project, again, where the power of the consortium really came in to help solve those. I mean, I think access to the site and the field on a regular basis was something we needed to be able to actually test out the hardware. I think COVID threw a bit of a wrench in that. We weren't able to send people out as often as we would have liked, but actually we found a way of working on a remote basis to deliver the technology throughout the program, and we're just in the process of delivering the demonstrator at the moment. I think what's been quite interesting here as well is we're dealing with several stakeholders, from site operatives to project managers to planners to designers. When you're dealing with a factory, a project site, building out a product for such a diverse set of personas is something that the consortium really helped support. And ultimately, in terms of impact, I mean, as a consortium, we're providing a componentized solution that provides a 60% increase in productivity and a 30% reduction in build times, and also evidencing a lower carbon life cycle by actually targeting a 30% reduction in operational carbon during that asset's life. So fundamentally supporting MMC and the wider kind of strategic objectives that are set really at government level in the UK in terms of shifting to these new ways of building. Yeah, so I think that's really a brief overview of the 3 grant projects that Converge has been involved in that really span AI-based systems, piling, as well as kind of kits of parts, and generally the use of sensors to optimize the construction process across a wide variety of sectors in construction. So a big thank you to Innovate UK and the funding bodies involved for supporting this. I think it's been really a kind of a great program for a startup like ourselves to be able to work with leading industry players. Big thank you to our consortium partners as well, and happy to answer any questions.
That's fantastic. Thank you so much, Raphael. And can I just make sure everyone else turns their cameras back on? Raphael, if you can stop sharing, because now we can go back into a Q&A session. So what is fantastic is, first of all, lots of people are still with us, which is always good. So you've obviously kept everybody's interest. I also am very excited by the fact that a huge number of the questions have already been answered by John, Franco, who have been exceedingly busy typing away whilst people have been presenting. So first of all, thank you to Dan and to John and to Franco, because that means we've only got 4 questions we need to answer live, which makes life very simple. It means I can also ask some questions too. I think before I ask questions, I think there's a couple of reflections I want to make about the group of presentations. I think from one perspective is, I think this really shows the huge potential of new products within the construction sector, and really showing the span of digital transformation that's happening. I think for me, one of the things which is also very, very exciting is sort of bust a whole bunch of myths around who the people are who are innovating. Because quite often, if you look at the world of tech, it becomes this kind of caricature of people who are very much in their kind of early 20s. And I think what's really exciting for me is it shows that not only have we got people who are real new entrants into the sector, who may have come from other places, Raphael, come from the world of physics, but also people who come from real deep expertise in terms of QS and architecture, and who are also embracing new technologies as ways to help the sector transform. And I think for me, it's that that breadth of experience is really exciting. I think one of the other things which has been a real sort of alignment across every single one of the projects that I've seen is actually how critical collaboration is within our sector. So we talk about collaboration as being something that is part of transforming construction, and I think it was very much evidenced by every single project that's been talked about, and actually how fundamental and how different that is to many other sectors that I see, and something that is really unique and special. I think there's for me some questions around the future, and I think this is something I'd really like to explore with a couple of you, which is actually, it's great to see where we are now, but what I'd really love to see is how things are going to develop. And so before I get into that, I'm going to ask a few questions that have come in from people. So first of all, question for Rob. There's a kind of question from Charlotte, which is around, actually, are your elements, are they hosted objects? How do they attach? So it's a bit of a technical question. Are you able to see it, or shall I read it out for you?
I could hear it. I lost connection and I restarted. I've only got like the last 2 questions. I think I remember what it said. And I think the answer to this is it doesn't in SketchUp, because SketchUp doesn't have that functionality. I think hosting is a Revit thing, but there are parallels in Vectorworks and Architect. And I guess what's quite interesting about the platform that we've built is that the browser that pops up is ubiquitous between all of those BIM products. And then from that point of insertion, each of the packages has its own idiosyncrasies. And we're working our way through those programs to using their open APIs to make sure that our products have the maximum functionality within those products. We've focused on SketchUp first. I know it's maybe not a proper real BIM package, but everybody has it. All the architects use it. You don't have to. It's free for joiners and for kitchen designers as well. So it was just the biggest market. Its API is very easy. It uses Ruby, and it was quite a nice one to start with. But the back end of our system is the same. So it's just a case of when it comes into Revit, we need to make sure that it attaches to those. It uses that host functionality, which it should do.
And just staying with you. So just staying with you for a second. Right, sorry, just one additional question from my side, Rob, which has one of the things which I thought was really interesting is when we talk a lot about products, it's often in new houses, and I love the way that your product can be used almost as a sort of tailored approach for either embedding a product into a retrofit, or it could be something that's new. So, I suppose what I had a question is, who's the main audience for your product? Is it about people who've got their own house? Is it for kind of small architecture firms who are wanting to kind of bespoke things? Or is this about scaled use for large house builders? Where do you see the real market for this?
It's a really good question, and one that we don't necessarily fit into to the typical kind of what's your target market kind of question, because you have a slightly strange scenario in construction that isn't like a lot of other industries, whereby the decision maker or the kind of sales coach, if you like, might be the architect or designer. The person that actually makes the decision is the client, and the actual person that pays you the money is quite often the contractor. So that situation is a kind of collaborative mess when you try and discuss it against a normal kind of business plan. And so I'm not trying to deflect your question, but to answer your question is probably, it could be all of those. At the moment, our focus is that, you know, the people that are using our product properly are architects and design professionals. It then gets delivered to site. It isn't IKEA in so much as CAMS, and it comes with, you know, you do need some level of expertise. You know, the floors are out, the walls are out, you still need to scribe in panels. You know, it's high-end joinery, and it does require a level of skill. But quite a lot of our products have gone to kind of self-builds, architects themselves that do up their own houses. Anybody that can use, that's got some you know 18-volt power tools, I can kind of get on with it. And yeah, we're finding that actually we don't know exactly where to focus that at the moment, because it could go in lots of different directions. We've done a few developer projects where there's been 6 or 7 kitchens which are all very similar, slight variations on each one, and that's worked out very well, because the design work that you need to do at the front end is kind of less than the very bespoke one-off kind of things. So all of those really is the answer. We're just kind of building the platform, and we'll see where the market wants to take it.
It is interesting, because if I see some parallels in terms of things like fashion, it's almost where it's almost that hybrid between almost bespoke, but it's tailored. So it's that way that you can have almost that sort of bespoke experience of something that really fits what you need, without having to do that full cost of going to Savile Row and having a suit cut exactly made to measure. I think sort of coming on to some of the other...
That's a good analogy. Yeah, that's a good analogy. I mean, a suit which is tailored to fit somebody is made to fit. It's still quite often the same kind of looking suit. It's not a kind of I don't know, dress or something like that. You know, it's the same thing, but it is tailored rather than being a complete new one-off.
And I'm just sort of going to hand over. I've got a couple of questions, Franco and John. You've been so efficient about answering all of them online that I'm just going to ask you a couple directly. So one of the things which I think is really interesting is how, if I think about when you talk about the lifespan of your buildings being 60 years, how does that work with people who are buying homes and kind of mortgage providers, where you might think that a home is for life? So if I think about, you know, my father-in-law's house, which is, you know, from I think 1902 or something, you know, how do we deal with this piece which is around the lifespan of what is a home, and how do mortgage providers and people like that, what's their view around a home which lasts for, you know, it's only got a lifespan of 60 years?
Very interesting, Frank. If you don't mind, I'll have a go at answering that. I think there's a bit of a misconception about you know, how long a house will actually survive, and this mythical 60-year lifespan, which appears to be a timeline imposed upon homeowners by lenders. You're quite right, Elspeth. Your parents' home is, you know, already 100 years old, 110 years old. When a home is designed properly and it's designed to withstand weather, and that the external cladding is robust and appropriate, there is no lifespan as long as it's maintained correctly. And I think, you know, as we move forward in life with more off-site fabricated homes, that will become the norm. So I hope that answers the question, but I think it's a mythical concept. And as a major landlord in the Midlands, we are now looking to regenerate stock that is 80 years old, simply because they don't meet energy efficient standards. They're not falling over, they're not crumbling away, but they're hard to treat, and they can't be upgraded to a standard that we think our customers deserve. And that is the driver for some of this, rather than the fact that the house or the fabric itself is failing or falling over.
So are you saying that, so just to sort of build on that is, so who's the target market for this? Because do you still have that same ability to do DIY in your home if it's from your model, as you would do if you have a traditional home? I've got a Georgian cottage, so you know, what's your ability to tinker and to go down to kind of B&Q at the weekend and start to, you know, still have that personalization you want to have?
I think tinkering and maintenance are probably two very different things. Maintenance can be built in to offsite fabricated homes because you've got all of the service runs and everything is designed like a car. I mean, we have to accept that we're not taking our basis from the motor industry, and you know, maintenance on a standard Fiesta or a standard Golf is always the same, so that can, you know, create efficiencies in maintenance. To be able to tinker and customize, I think, is not too much of a restriction, provided that the structure in which it's originally built from is understood by anyone that's going to modify it. And I think that will be the health and safety plan type information that will inform what you can and can't do. I don't think it should be restricted any other way than any other traditional built home, to be honest.
Okay.
Perhaps the only exception would be the envelope. I think, like, you know, there will be very, you know, limited amount of like a change of behavior. I think, like, perhaps the user needs to be educated, to be a bit more careful about, you know, certain aspect. But other than that, I think most of the changes you would expect from a social tenant's perspective, particularly because, you know, WHG is a housing association. The anticipation is that it wouldn't be significantly different.
So are you anticipating that in the future? And I'd love to kind of bring Dan into this piece as well. So are you imagining in the future, so if you're going to your local hardware store, there's going to be like a section for your MMC home alongside all of the normal, you know, paint palettes, normal sort of joinery pieces? So are you anticipating kind of new kind of how those kit parts will form part of your DIY experience? What are you imagining there?
John, you want to start?
Yeah, I'm delighted. I mean, we've taken the work that we've done with our collaborative approach sort of further towards standardizing components within the home. I'm really, really excited, perhaps, to engage with our three other speakers. Let's take kitchens and staircases, for example. If we could standardize that through a range of house types, then to replace that or to repair that or to, you know, redecorate that it becomes easier, cheaper, and far more efficient. And let's not get too carried away with this concept that you know, offsite manufacture is some spooky new way of putting things together. We've got, you know, standard door sets, kitchens, bathrooms, everything is standard. We haven't reinvented the bath, for example, to make it fit our house. It's bath. So as long as the fabric and structure is understood and that the fabric performs, is maintained to perform as it's intended, there's no mystery, and I don't think there's anything special about it.
Yeah, I think it's a bit of stage thing. For example, you know, if you're talking about you make your own kitchen cabinets 50, 60 years ago, you know, you wouldn't imagine that, you know, at that point there will be different standardized, you know, cabinets that you can just buy them and then put them together on the site. And then one example of the use of kits or parts within this DFMA project is that the window itself, it has a port design, which means that when you replace a window, you won't change, you won't damage the interface and affect the energy performance. So this is one example that, if you want to do maintenance and replacement, it'd be more direct and easier. But I think it's a stage thing. We will expect that perhaps in the future, more parts or components will be standardized or will be able to allow users to customize. But I think, it will take some time to develop to the stage that, every single part is like, you go to a home base or like B&Q to find that particular kit that allows you to just replace directly.
I think what's interesting is if I live in the Barbican, and so which is very much kit parts, and it's also if you look back at the things like the 1920s, there was a lot of actually standard components and actually standard templated homes, which is why so many houses look the same even though they were built by different builders. So I think one of the things is that nothing is ever new. It's just a new way of doing something that was always done before. I'd love to bring Dan, you into this kind of conversation around, how you see this evolving from a data perspective, and because obviously that's a massive part of a new home, and you talk very much around some of the risks around IoT that you're also tackling as well. So can I just sort of bring you into how do you see this evolving going forward?
Yeah, sure, thanks. I mean, I live in a 1940s built house. I remodeled the ground floor of my house about 3 years ago, and I couldn't even get hold of the floor plans for my house. And I had, so let alone knowing what the walls were made of, let alone knowing what was behind the plaster. I think from my perspective, there's no excuse for not delivering a proper O&M handover pack to new homeowners when they buy the house. The danger from an architect's perspective is they're worried about their IP being compromised. You could take that user information and build another house next door, and the architect loses out on fees. I think that kind of approach needs to be rethought from across the board. It's a bit of a challenging conversation to have within some kind of architectural spheres, and no one wants to have their IP compromised. But I think there's definitely a middle ground where the right kind of information can be provided at the point where the home is handed over to allow for homes to be modified more efficiently. Our hope is that homes that are built using our platform, people then use our user interface to engage with us if they want structural modifications, then we can actually represent a pre-qualified set of tradesmen that know about the home and have access to all of the information before they even price the project, so they can accurately price the project. There's no surprises. Everything's much more efficient and everything's much more much happier from both sides of the fence. So I think there's a huge amount of there's a huge part to play in terms of data. There is, wherever data is mentioned, it always starts to get a little bit emotional, and people say who owns the data and everything. There are some challenges to work out, and there's definitely some security challenges to work out. But I think the opportunity exists to really help home modifications in the future by providing the right information in the first place.
I think when talking about data, this is a good time to hand over to Raphael, because obviously you're kind of absolute data king and focused on AI. So I think one thing from my side, which would be really good to understand, is it feels like everything is evolving really quickly. So you're obviously very focused around tracking, things like curing concrete and how effective structures are within buildings. But how can we also be better at really collaborating as a sector, especially kind of almost a post-transforming construction, because obviously this is a very fast-moving industry. So I'd be interested in finding out two things from you, which is one, what do you think some of the challenges are in sharing data? And two, how can we be better at continuing these conversations? I know that Hannah's on the call here as well, but that for me is obviously something that we also need to continue to do as an industry as well.
Yeah, absolutely. And obviously, I mean, data is fundamentally key to us being able to deliver value back to the industry. I think to kind of maybe answer the second question first, and I'll come back to your question about data. I mean, in terms of collaboration, beyond the funding, right, and the capital that was sort of injected through the TCC program and the grants, I think one of the most useful aspects of it was really the framework of bringing together startups, SMEs, and construction groups, and providing kind of access to sites, access to environments where you can test, products, certainly from our perspective, I think that was invaluable in driving learning. And so actually kind of establishing that consortium structure and driving kind of the project forward is something that really helps on the collaboration front around sort of adoption. And I'd really recommend it to any other startup that's looking to learn more about the industry. I mean, as you rightly pointed out earlier, I'm a physicist from outside the construction sector, but I do think construction expertise is very much necessary to being able to innovate in the sector. And essentially, we've managed to, I guess, bring that into the business on the Converge side in two ways: either hiring people from within the construction sector into our team, or establishing really close knit relationships with our customers, so that we kind of gain access to the sites on a sort of day in, day out basis. So that's probably the answer to the sort of question around collaboration, around how do we get better at sharing data. I think we probably need to kind of educate ourselves a bit more across the industry as to, I mean, what do we even mean by data ownership? Data are a digital asset. They can be duplicated, copied. Multiple people can have a license to data. And I think there's, in some senses and in some cases, a lot of uneasiness around sharing data because we think we're potentially giving something away, but actually, I mean, data are the raw material, not the work product. And so we need to think of them as that kind of raw material, but it's also raw material that you can duplicate as often as you'd want. So certainly on the, I guess, startup side of the equation, I mean, I've been in situations where, we were missing a key piece of data, and there was uneasiness about sharing that data for various reasons, whether those are sort of cultural or just sort of a view that there might be some value there that you kind of want to keep a hold on, and unfortunately that means that then you don't achieve kind of the objective. Now that wasn't the context at all of these grants, where actually we were able to kind of get access to the key data sets we needed, whether it's the mix design for concrete or that kind of drives our ability to predict its behavior. All I can say is whenever a customer has shared data with us, we've actually been able to deliver a way bigger return by actually being able to provide kind of value back to the industry. So we probably need to educate ourselves around, like, what does data ownership mean? What does data licensing mean? And how do we get comfortable that we get the right kind of data licensing arrangements across the sector? And two, how do we kind of create an open ecosystem where everybody's kind of actually comfortable providing access to those data?
Yeah, and I think there's some really good work around things like Golden Thread as well, which really focuses around actually what data is really important to share and how do we protect it. I want to say thank you to all of you for your presentations today and for seamlessly coming in at different times and making sure that we could continue the discussion. So a big thank you to all of you who were presenting. So John, Franco, Raphael, and Rob, and Dan. So thank you very much. I'm now going to hand back over to Mary.
So thank you very much. As ever, we've run out of time, and what usually happens with the Smart Construction Forums is we could go on for at least another hour, and it would be brilliant if we could do it over a drink in a bar. I always say this at the end, people must get fed up with me saying it, and I did say it to Elspeth that we would definitely run out of time. So from me, I think Elspeth has said thank you to all our presenters. It's really brilliant to sort of bring the projects alive. I would say that for those of you that are interested in what the Transforming Construction Challenge are doing, the website is a brilliant resource, and I spent quite a lot of time looking there. But actually having presenters present their projects does bring it alive, so that's wonderful. Hannah Gibson from UK Transforming Construction has really big shout out to her because she sort of brought everybody together. Thank you so much. And she has put in the chat that there is another event on Monday the 11th, the Enabling Housing for Inclusive Growth project. We will send out all the presentations and details of the further events to all the participants, so don't worry about that. We'll probably have to do a file share link with you, I think. So it just for me, it's an end just to say our next Smart Construction meeting will be on the 23rd of November. I will send out the details. That will be a session just for the members, and we'll be focusing on the future and what members want us to do going forward. So as I say, we'll send out those details to all of you here and to all other people who are members of the Smart Construction Group. But with that wonderful timekeeping from Elspeth and everybody else, thank you so much, and goodbye. Yes, and as I say, we've got all your details, so we will be sending out the presentations. Give us a bit of a leeway. We'll do them within the week, but they'll definitely be out to you. And you can also get a CPD certificate for this, for those of you who would like those. So another plus for that. So thank you very much, everybody. Goodbye.
Thank you.
Yes.